Hello everyone, I am Nex and welcome to our 16th lesson, Introduction to Trigonometry. This is the first of the 3 videos that I'm gonna make on this topic. The first one will be an introduction, so today. The next one, so in 2 weeks, will be like more about what it actually is, where the ratios and everything comes from, how the graphs look, and then the third video will be mostly the actual application in science, maths, and world, and like the formulas, more into the formulas. I'll shift details front and back a bit, but for now, that's just the general direction we're taking the trigonometry in. So actually, this is also the first lesson in which we'll have to use a calculator, but do not worry, if you do not know how to use it, I'll have a general calculator image and show you what buttons there are so you can follow along. You may be wondering, what does trigonometry have to do with ratios and right triangles? And I'm here to tell you. They have everything to do with them. Trigonometric functions are essentially ratios of sides in the right triangle. Well, sort of. Trigonometry, or as it's often referred to as trig for short, connects angles and sides of right triangle, allowing us to use that knowledge in many more different ways, similar to how we had complex numbers last time. Today we'll have an introduction to the main 3 or 4 functions, and I'll mention their inverses, because every function, well, not every, but like a lot of functions do have their inverses, but we'll get to those in due time. As you can already see, I have marked sine as sin, cosine marked as cos, and tangent marked as tan or tg, which are the most common 2 markings. Of course, there's also cotangent, which will be marked as cot or CTG, depending on the source, but we won't be touching it as much other than defining what it is, and maybe to make one exercise slightly harder or to show another aspect. Another important marking, which I have shown last time, but will start being more important now, is theta. Greek letter, with which we will mark the angles. You can use any other Greek letter like alpha, beta, gamma, delta, epsilon, but theta is just more often used in these examples, so trigonometric functions. Sometimes it's also marked just as x. I'll be using theta in this video, and I think in the mini-test, but maybe in the future I may be using x just to make it easier on the brain, depending on whatever we're working with. At the end of the day, the marking of any variable or constant does not matter as long as you specify what it actually means. You could mark velocity with a random circular scribble as long as you mark somewhere that scribble means velocity, or like define it with the formula. And last markings that we'll cover are O, which stands for the triangle side that is opposite to the angle. So like here we have theta. O to theta would be this one. A is the adjacent one, so the one right next to it, so the one that's touching it. And the H will be hypotenuse, which is the longest side in the right triangle, and the one opposite to the right angle, so the 90-degree angle. This angle can also be marked with a tiny square, or completion of a tiny square here in the corner, and you don't need the number written, but I wrote both just so it's easier. In the right corner I have marked theta, as you can see. It could be the other sharp corner too, which means that we would have to account for that. So like, if we have theta here, the opposite side from this theta is this one. So I could technically mark this O of theta, and then up here would be theta dash, and then this would be O theta dash. Basically, the opposite side is the one that is the opposite of the theta. But as I'll later show, I'll change the letters around so it's easier to follow along. But yeah, these are the 2 ways to write theta. This one is the digital, the left one is digital, and the right one is by hand. You can also use the left one. You can also just do the circle and cross it across the center horizontally. All of these are accepted. And yeah, more often we'll have triangles marked with A, B, and C, as I said before. And the opposite angle is marked as the corresponding Greek letter. So, I'm confused now. A is here and alpha is here. Alpha is opposite of A. B is here. Sorry, oh my god, I'm confused now. B is here and beta is here, and beta is the opposite of B. And C is here and gamma is here, so like that. Which means that when we have an ABC triangle, if we're looking at alpha, the opposite to alpha, so the O in this case would be A, and adjacent would be B, and hypotenuse would be C, which is always. As for beta, B would be the opposite, and A would be adjacent. So do keep that in mind. The O, A, and H are relative. Well, H is always there because it's like the longest one, but like O and A are relative. But if you have the general markings like A, B, and C, they're constant. You just gotta follow along with those rules and the ratios, but we'll cover them in a bit. So do not worry, there's a special mnemonic device for you to remember them. And just in case you do not know the basics of triangles, because we didn't cover them, so I will assume that we do not know them. The first main property is that the sum of inner angles is 180 degrees. We could have a formula. I might make a short one day for that, but there won't be a special lesson for that. So in the right triangle, we have one that is always 90 degrees. Then we will have a theta and theta dash, which is a marking I'll use more in physics or chemistry, and it refers to something that is a part of the same group but has a different value or structure or behavior. So basically, use either the same letter or symbol and add a star, dash, comma, numerical label, the letter having to be in the bottom as the top is reserved for exponents. But you can also just use a different marking, so like alpha and beta, whatever. So essentially this formula here, if you have one angle and you know that it is a right triangle, you just subtract that known angle from 90, because, well, 180 minus 90, because we always know in a right triangle, one is 90 degrees. So the other two sum up to 90. So if we know one of these two, take 90 minus that angle and you get the third one. Simple. And if you remember the second marking, A, B, C, alpha, beta, gamma, the next property is that the wider the angle, the longer the side. So technically, the angle defines how long the side will be. Here I'll write this in the general form, that the opposite side from the theta is proportional to theta itself. The wiggly half infinity sign means to be proportional to, as in the greater the theta, the greater its opposite side will be, which is a crucial foreshadowing for one property that we will cover on the second or third video, and it's one of the main formulas for the triangles as well, so don't worry, we're not complicating too much with formulas today, just a bit of ratios. These are the two main properties we will need. Of course, Pythagorean theorem. Hopefully you still remember that one, a squared plus b squared is c squared. As I won't be covering geometry in the foreseen future, I also won't be dragging too much into the lessons that isn't important to the topic at hand. So if we're working with trigonometry, I'm not gonna be dragging in squares, for instance. And here are the three most common ways to solve a right triangle, based on the information you have about it, of course. The first one is if you know two sides, and preferably which sides they are. You can use the Pythagorean theorem to get the third one. And there is a way to get the angle that is opposite to the two that aren't hypotenuse, but more on this in later in this video and in other videos. The second way is if you know one side and one acute angle, either the adjacent or the opposite one. Using the trigonometry, you will be able to find the other sides, and from them all other angles. And last, which we have mentioned, is when you know two angles, so we subtract them from 180. These are the main right triangles, and the last one applies to all triangles. So if you know two angles, 180 minus two angles is the third one. Other two don't really directly, but you would have to modify the formulas and process, but the last one is for all triangles and the first two are just for the right triangles. That's all that matters for us. Finally, after yapping for about 20 minutes, when only like 5 or max 10 will make it into the video, we get to trigonometry, or trig for short. I will reuse the triangle from before and write out all 4 most common trigonometric functions: sine, cosine, tangent, and cotangent. Now let's write out their ratios. Sine is the ratio between the opposite and the hypotenuse. So we have theta here. We write this as a normal function we would have. So f of x here is like an f of theta, and f is replaced by sine. So like this. We have sine here, theta here, and the sine states opposite over hypotenuse. Then we have cosine, which is the ratio between the adjacent side and the hypotenuse. So we have theta here, which is adjacent side divided by hypotenuse. Then we have the tangent, which is the ratio. So the tangent of the angle is the ratio between the opposite and adjacent side. And lastly, cotangent is the actual inverse of tangent. So like not an inverse function of it, but like reciprocal. I mentioned that more later, but it's 1 divided by tangent, so the adjacent over opposite side. So not to be mistaken, cosine to sine is not the same thing as cotangent is to tangent. It is just a very unfortunate naming. All of this can give us a very handy mnemonic device. My language has one, which has helped me big time, but it's not translatable into English. Fortunately for you, there is one, which I frankly don't understand, but it's a funny sequence of letters, I guess. Don't worry, even if it doesn't stick, in the next video I'll show you how these functions behave, and maybe then you'll be able to like find a way to remember them. But yes, the mnemonic device is SOH CAH TOA, or SOH CAH TOA. You may be wondering what the hell this is. Well, it stands for sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. You can either do your best to remember these 9 letters, or find a short story of sorts, as the internet is oversaturated with like, when I was looking up if there's like a good story that I could give as an example, there was like at least 29 results in the first page that I saw, then like 30 on the second, 10 on the third. So you have plenty of material. If you really want to remember this from association to the story, go ahead, be my guest. But this is the least we need. I hope this was easy to follow and remember. If not, again, next lesson I will show you their behavior, and it might be easier for some of you to understand them. But for now, if I wanted to explain that, it would take like 2 times longer, which will make for harder for the average person to pay attention to this video, because as we all know, the lesson will only work if it's short and compact and digestible. If I make an hour, 50-minute long video about trigonometry, I'm sure no one's gonna make it past 10-minute mark unless they're actually learning. And since most of you are here just to support me or are interested in the topic, you're gonna skim through the video, as I encourage you, learn whatever you think you need to learn, but watching the entire video doesn't do harm, just takes 10 more minutes. So here we have a triangle with angles 30, 60, and 90 for our first example, and we need to find the ratios between the sides. For that, we'll have to solve the trigonometric functions with their angles inserted. Then set one of the sides to 1 and adjust the rest so it's actually a ratio of that side towards the 1. So let's get into it, and I will show you how I would have solved this. I also marked the sides with A, B, and C so we can keep the same symbols in all the solutions. First we have, let's analyze this angle 30 degrees. I will write out sine of 30 degrees is A over C, so the opposite over hypotenuse, so SOH. Now to know what sine of 30 degrees is, we pull out our calculators. On some, you may have to press the sin button first and then insert the number. On others, you put the number first and then use the sin button. If your calculator is writing out formulas like this one up here, so you can see what you previously typed, you're probably going to have to use the sign first and then put in the number. If you only see the number you're currently working with, so the result of what you have written so far, then you need to write the number in and then use the sign function on it. The button to press is this, the one circled in red. And on the type of the calculator that is here, you also need to close the bracket, which I have circled white. The other ones just automatically apply the function. After that, you would press the equal sign and get the result. Before you do though, make sure your calculator has a symbol or a word that says DEG or D at the top. This one has R right here, so the result would not be correct. I circled this with blue. We will learn about this in our next lesson, as I don't want to overcomplicate the introduction. Just make sure that whenever you're working with degrees like this, the D and deg stand for degrees. So when you're working with this tiny symbol, so 30 degrees, whatever like that, make sure it's D or deg. because otherwise you're gonna be calculating in the wrong units, but more about those units in the next video. The phone calculator won't say anything on the side if you're doing it right, and if you have the R on your phone, so like rad or R, that's gonna be solving it wrongly, so D or DEG is what we're using in this video. Now that we know what to press, we put in 30 on DEG settings and press the sin function and we get 0.5, which is 1/2. Now this doesn't mean that A is 1 and C is 2, but it means that C is 2 times longer than A is. Now since we want ratios, I'll take the shortest side, which is A in this case, as it is the opposite of the smallest angle, and I will set its value to 1. So we are looking at ratios of other sides compared to A. That is why I wrote A divided by B divided by C on top. So as that is how you write ratios in these examples, and I have already fixated where the 1 and 2 are. Now to avoid the complications, we could use the formula that uses A and B. That way we can get the precise ratio without complicating anything. But you know me, when I can make something harder, I definitely will do my best to do it. But I will keep it easy enough to be solvable. So here we will find the function with B and C. Here we can use sine of 60, which equals B divided by C, or we can use cosine of 30, so like sine of 60 is the B over C, or we can, sorry, am I crazy? Yeah, I am. And then cosine of 30 is B over C, because it's like a different function. We already used sine, so let's do cosine this time. And now we'll do the same thing on the calculator as before. This time selecting the cos function, so right here. But make sure again, DEG or D is showing up there. Then press cosine over the value, so 30 degrees. And our result will be 0.8660254, etc. Did we do this right? Of course we did. And we got something that doesn't look like a nice number, but let me tell you a little magic trick, which we will learn more about the next time probably. We can rewrite this as a fraction with denominator as 2 and the numerator as whatever we just got multiplied by 2. So we multiply both this number with 2 and then write it as a fraction. This still feels weird, but I guarantee you some of you may already know what this is. Some of you will realize in a second. I realized right now that I'm an idiot and I forgot to hide this beforehand. But yes, this number squared gives us 3. So our result is square root of 3, which equals 1.73205, etc., divided by 2, which in decimal writing is this number. This means that our B to C ratios is square root of 3 divided by 2. Now C is 2 again, so we don't have to adjust for it, but if our C here was 1 or any other number, we would have to multiply or divide both sides of the fraction line to make sure that the bottom line will beat 2. Here it's simple, it's already 2, so we have B as a square root of 3. This gives us our result that when a triangle has angles 30, 60 and 90 degrees, our sides will be in the ratio of 1 to the square root of 3 to the 2. And we can quickly check this with Pythagorean theorem. A squared plus B squared is C squared, so 1 plus 3 is 4, 4 is 4, we solved it correctly. For our next example, we know our theta is 40 degrees, hypotenuse is 10 centimeters long, and we need to solve for the distance of the opposite side from the given angle. So we need a function of the angle that equals to the ratio of the opposite over hypotenuse, or opposite over adjacent, or whatever. And the first one that comes to my mind, the simplest one, is sine, because it's sine of theta is opposite over hypotenuse. So I'll replace theta with 40 degrees, equals to this ratio. Then I multiply both sides with hypotenuse, so I can isolate the length of the opposite side, like this. And then I insert the rest of the numbers. So we have sine of 40 degrees times 10 centimeters. Since there's these functions like sine and logarithms and everything, they prefer numbers without units, or they remove the units if you put them in. The output of this function will be a non-united thing. This is going to be much more important in physics. Right here, it doesn't matter as much, but I will still try to lead you into it. So this left part does not have a unit, despite the degrees being here. And when we multiply it to centimeters, we get centimeters. if we somehow get centimeters inside of sine, they would most likely disappear. But then again, depends on what we're working with, so yeah. Anyway, if we follow the same steps from before on the calculator, put in 40, enter it in the same sine function, then multiply that with 10. Sine of 40 is about 0.6428, and when we multiply that with 10, we get 6.43, as we will be using 3 significant figures, but more on that in our statistics lesson, and that was our result. Next is inverse trigonometric functions. Not the inverse like 1 divided by them, but like the inverse functions where you switch the y and x and then solve for y again. Let's see how they are written and solved for. I went ahead and swapped the theta with the ratio and already changed the markings to show it is an inverse function. But these inverse functions have their names, as power of -1 could be deceiving and make some students write 1 divided by the function. That's why there's a separate naming, and so the inverse functions are called arcus functions or arc functions, which comes from their relationship between the angle and the arc it subtends on a unit circle. This is just a fancy definition. I'll show it practically next time, as otherwise this would drag on for hours. But the markings are like such. So sine becomes arcsine, cosine, arccosine, and tangent, arctangent, and cotangent, arccotangent. The normal functions, so sine, cosine, tangent, cotangent, they take the angle, so the degrees, as their input. You do not put in ratios in them. However, the arcus functions, so arc functions, they take the ratios in and do not take the angles, so you keep that in mind. Arcus functions take in the ratio of sides in the triangle. Trigonometric functions take in the angles. On the calculator, you would find them by navigating like this. You probably see this small sine to the power of -1 above the sine button, and it's written in yellow, circled in red, of course. So why don't we go to like the button labeled shift colored and circled yellow, we press it and then select the function here. Let's say sine for this example, and it's circled in red. It should automatically use the arcsine function. Then we just put in the number and end with a bracket and equals. For the other type of calculators, you might have a button saying something like second or alternate, alt, and you basically do the number you want to run into the function, then press the second button so the calculator knows that whatever you press next will apply an alternate run, usually the one written above the button, and then press the function you want. Sadly, I couldn't find a good quality image of the calculator with such button markings, but I do have one that I use for my uni and lab stuff, and it's just like a simple one. Most of these functions are not present on my calculator, but yeah. Do not be distracted. Arcus functions are up here, so the alternate. The same thing here. If you wanted to square something, you press this button. If you want it cubed, you press this one. If you want a root with a power, I forgot the word again. Oh my god, I don't even remember my own videos. With the power of the root being up here, you press shift. If you want 10 to some power, you press shift, etc. But yes, that's about that on the guide. You will also often see the functions written as sine to the power of -1, which just looks like it's a reciprocal, as I said before, but it is in fact just an inverse function, so I introduced this so you wouldn't get confused later on. This would be easier with graphs, but I must unfortunately withhold that until next video because there is quite a decent amount of information that I still need to present for that to make sense. So for our first example, let's clear our minds of all the complicated circles and stuff we've seen, and let's solve this easy example. We have a ratio given as a solution to the tangent of the angle, so our job is to find the angle. And for that we'll use the arcus tangent or arctangent or whatever we're calling it. We click shift, we click the tangent button, so it automatically inserts the inverse of it, and then insert in 3/4, and then enter, because we swapped the ratio into the arcus function, and then the angle comes out on the other side. In our example, the number is 3/4, so the result of our theta, so arctan of 3/4 is 36.9 degrees. Technically it's 36.87, which rounds up to answer, and that is it. Simple, right? It's not really complicated, it just looks harder than it is. For our next example, we will use arcus cosine. Since cosine of theta is 5 divided by 8, we will take the arc cosine of 5 divided by 8 to get theta. And that is 52.32, but we will round that down to 52.3 degrees. So to sum it up, the numbers you put in the normal trigonometric functions like sine, cosine, and cotangent of course, will always be angles, and the result will always, or most of the time, be a ratio between two appropriate sides as determined by their formulas, but they will always have to be between -1 and +1. More on that in the next video, of course. The numbers that you put in the inverse trigonometric functions, aka arcus functions, will always be ratios, and the result will be an angle. And of course, do not dare forget the Pythagorean theorem, because triangles, man, like, whenever you go to triangles, this guy's gonna appear. Pretty much half of the math. But yeah. So thank you for this short videos present. I'm pretty sure this is gonna cut to like 20 minutes. That's gonna be one of the shortest ones I made so far, other than shorts. I have been... Oh shit, sorry. Here is the mini test, of course. Best of luck solving it. I have been a bit sadistic, and I gave you a very hard one on the third exercise. But do not worry, it is very solvable if you have listened to my previous lessons. As for the every 2-week bi-weekly update, I am thinking about making shorter videos, not shorts, in which I just explain the concept we have already covered. Like in Minecraft, for instance, I could go with exponential functions, exponential growth in Minecraft, where I compare items in chests or numbers of blocks. Or I can just do practical, like how many seconds in a year, how many seconds in eternity, etc. So these types of things, where we have already covered something, and then I can refer it from the video. And you can also have another interactive way of looking at it, and you can also do it in your own Minecraft world by yourself, so you can also learn while physically doing the thing itself. So let me know if you're interested in that down in the comments. Join my Discord if you have any more questions, or comment down below. I'm always scouting my comments to anyone that comments. I am so happy when I see you guys there. And yeah, you can also interact with me on Twitter. I am becoming slightly more active. But yeah, thank you so much. If you liked, subscribe. If not, that's okay. Take it your path. And I'll see you guys on our next quest. Bye bye.